Salam everyone and welcome back. In our last episode, we explored autocorrelation function and partial autocorrelation function. Today, we are diving into our first classical forecasting method, the autoregressive model. Let us get started. An autoregressive model, or simply AR, is a time series forecasting method where future values are predicted based on a linear combination of past values. That's how the model got its name. It predicts future values based on the regression of past or auto values. The AR model has a main key parameter, P, which defines the number of previous values or lags used to predict future values. This parameter is referred to as the order of the AR model. You might think that including more past values in the forecasting process would always improve the model, but that's not necessarily true. A high value of P can lead to overfitting, where the model captures noise rather than meaningful patterns, making it less effective at generalizing to new values. So, how do we determine the optimal number of lags to include? This process is known as order determination for the AR model. One common method to determine the value of P is by using the partial autocorrelation function. The optimal value of P is identified as the lag where the correlation is statistically significant and above the confidence level, with subsequent lags dropping close to zero. Let us see the AR model in action. By the way, you can find the full code of this example in the notebook linked in this video description. First, I generated a synthetic time series representing the monthly simple return of an asset. Then, I visualized the partial autocorrelation function to determine the best value for P. Notice that the last statistically significant lag above the confidence interval is lag 5. All lags after 5 are statistically insignificant, as their values fall below the confidence interval. Based on this analysis, we conclude that the optimal value of P for the AR model is 5. Next, I trained the autoregressive model, predict values for the next 12 months of return, and visualize the actual and predicted values on the same plot as you can see here. The results look like reasonably good for such a simple model. The last step in this example is to evaluate the model performance using mean square error. We got a MSE of 0.00202. The following visualization gives you a better idea about what the current MSE value means. That's it for today. In the next episode, we will explore the moving average model. If you have any question or feedback, feel free to leave it in the comments below. See you in the next episode. Salam.